Hello, geometry students. I appreciate you finding time to get your notes taken care of. Today we're going to begin looking at transformations in a way that we really haven't ever seen them before, and that would be to operate with them inside of graphs. So we're going to take the next 4 class days and we're going to look at the different transformations one at a time as they exist in the Cartesian coordinate plane. Let's take a look at our objectives. Your stated objective for today is the student will learn to apply translations to objects in the Cartesian coordinate plane. Now, you've worked with translations plenty of times before over the years. Not too difficult to deal with them out in just a plain old sheet of paper, but in the graph, a little bit of a different challenge in some instances. We'll take a look at that. Language objective, the student will demonstrate the ability to translate provided objects by indicated amounts within the Cartesian coordinate plane. And your essential question for today is, can I translate an object in a graph? As always, anytime you need more time to get something copied down, just press pause and then hit play when you're ready to move on. Okay, so let's get started. Now, a little bit of review here, but definitely information we're going to need as we move through the remainder of this unit. The name for the XY axis that we have been graphing on for years, as we talked about last unit, is called the Cartesian coordinate plane. Now, the Cartesian coordinate plane is simply a joining of 2 axes at a central location, which we call the origin. The x-axis is the horizontal axis, kind of like the number line that you've used since all the way back into elementary school. The x-axis is positive, moving to the right, and negative, moving to the left. And then it is intersected by the y-axis, which runs vertically. The y-axis is positive, moving upward, and negative, moving downward. Any location that exists in the Cartesian coordinate plane can be pinpointed precisely with the help of what we call an ordered pair. Now, as we saw last unit, an ordered pair is simply a joining of a location along the x-axis and then a location along the y-axis. We put them in parentheses. X-axis comes first, y-axis comes second. Easy to remember, it is alphabetical. Some of you are still struggling with this, even after we spent so much time working out in the hallway on those graphs. The x and the y values, you've probably never heard this before. They have official names that go along with them, and it's time that we learn what those vocabulary terms are. Okay, so let's take a look at our ordered pair, x comma y. The x value, its official technical name is called the abscissa. The y value, its name is the ordinate. We're getting these vocabulary terms because you will see these words used throughout the remainder of this unit. Dealing with transformations in the Cartesian coordinate plane is going to involve various changes to the abscissa and the ordinate. In fact, most of the transformations that we're going to see have a specific set of steps that you have to do, and typically it involves changing the abscissa and the ordinate. Sometimes it involves changing their values, sometimes it involves switching them with each other, sometimes it involves changing their signs, and sometimes it involves doing more than one of those things at once. Okay, so let's move on. The following is a basic rule when performing transformations within the Cartesian coordinate plane. We've started off with the transformations because they are the easiest to deal with within our graphs. Let's take a look how they work. A pre-image has points that are capital letters. Okay, so let's say we are looking at a four-sided polygon here, and its corner points are A, B, C, and D. After a transformation has been performed, we no longer call it the pre-image, the object. We don't call it the pre-image anymore. We now call it an image. And the notation changes on our polygon once the transformation has done its work. We use prime markers to identify the same points that have been transformed. So let's say something had happened to our quadrilateral. Maybe it was translated, like we're going to be doing today, downward. And to indicate that this figure is not the original figure that existed to begin with, a transformation happened, we relabel the figure A prime, B prime, C prime, and D prime. So when you see those prime markers, that is an indicator to you that a transformation has already taken place to this object. If our figure gets transformed further, which does happen from time to time, some problems have us perform more than one transformation within a graph before a problem is complete, we can use additional amounts of prime markers. So we could add an additional little mark, and we'd have A double prime, B double prime, C double prime, and D double prime. And if we transformed it again, we could add another one and have triple prime. It could be done as many times as are needed. Okay, so let's take a look at the translations specifically. Okay. Translations are really very simple to work with in the graph. Okay, they have much of the same properties as slope. Each point in a translation is going to move from wherever the pre-image is at to wherever the image needs to end up. And an easy way to think about that is it is moving with a certain rate of change, a certain slope. It is rising by some amount. It is running by some amount. Okay, so what we'd like to do is figure out what the rate of change is on our particular transformation and then cause everything to move by the same rate of change. Okay, so let's take a look at one. Here we have a triangle. Obviously, it is triangle ABC. And we are given an instruction to translate triangle ABC 6 units to the right. Now, many times when we do transformations, they have us moving more than one direction. But we're just getting started here, so we'll take it easy. So what we're going to do is, if we are going to move a triangle ABC 6 units to the right, well, much as we did with the basic transformations, we are going to move our object 1 point at a time rather than trying to move everything all at once. Okay, well, I'm just going to start off here and get my coordinates. Point A is at -6, 2. Point B is at -4, 5. And point C is at -1, 3. Now, being as this translation is moving right, that means our run is changing. The x values are going to change. There will be no change in the rise because we did not get asked to move our figure up or down. So basically, we expect all of our x values from our coordinates, all of our abscissas, to increase by 6 units. Okay, so let's take a look here. What are the coordinates of the new triangle going to be? Obviously, when we transform it, it's going to be A prime, B prime, and C prime. And let's take a look at where A prime, B prime, and C prime are going to end up. Okay, so I'm going to move point A. I'm going to move it over 6 units to the right, exactly like we were instructed. This will be the home for A prime, and A prime has a coordinate. It lines up with the x-axis at 0. Oh, we'll get to the coordinate here in a minute, sorry. I'm going to move point B. That'll be B prime. Going to move point C 6 units to the right. That'll be C prime. We connect the dots, and we have our transformed triangle. Okay, so we can forget about the red triangle now. Let's take a look. Okay, as we said, A prime lines up with the x-axis at the origin, that's 0, and A prime is on the y-axis at positive 2, so obviously it is at 0, positive 2. B prime lines up with the x-axis at positive 2, and then it lines up with the y-axis at positive 5. C prime lines up with the x-axis at positive 5 and the y-axis at positive 3. There are your coordinates, A prime, B prime, and C prime, after the translation has been performed. Not too bad. Now, a lot of times we are asked to perform more than one transformation at once, and a lot of times we are asked to move in multiple directions at once. But keep in mind, this is like slope, like rate of change. Okay, so we just figure out how our rise changes and how our run changes. So now we're given instruction to translate triangle A prime, B prime, C prime so that B double prime will be on the origin. Okay, so the first thing we're going to do is we're going to look at B double prime, and we're going to decide how it needs to change in order to actually reach the origin. Okay, so what are the coordinates of the new triangle going to be? Well, obviously, we're going to have A double prime, B double prime, C double prime. B prime is going to have to move down 5 and back 2. In order to reach the origin, which is where it was instructed to go. Okay, so dropping down 5 and back 2 in order to reach the origin would put a point right there, and that point would be B double prime. Now, obviously, if B double prime is going to drop down 5 and back 2, then A prime and C prime are going to have to follow suit. So if A prime drops down 5 and back 2, would place it there, and we label it. If C prime drops down 5 and back 2, that would place it there, label it, and we have our triangle. Okay, so let's get our coordinates. A double prime has an abscissa of -2. It has an ordinate of -3. B double prime is on the origin as instructed, so that's an easy coordinate for us to get. It is at 0, 0. C double prime lines up with the x-axis at 3, so it has an abscissa of 3. And it lines up with the y-axis at -2, so it has an ordinate of -2. Okay, transformation or translations, very easy to work with. Okay, you will see it'll get more challenging when we look at some of the other transformations. But jot down your summary, and notate any questions that you may have, and keep in mind your essential question. Can I translate an object in a graph? I appreciate you finding time to get your notes taken care of. We'll see you in class.